Hello everyone and welcome to ITLS Academy Empower the Youth. So today in this lecture we will going to understand ELISA, that is used in food safety, or you can say ELISA's application in food industry, and what is ELISA is, what is the different types of ELISA, and how ELISA works in safety of food and food based product. So, first of all, ELISA stands for enzyme linked immunosorbent assay, and it is one of the most widely contemporary method that is used in food industry. So, what ELISA does? So, ELISA method, it detects the actual allergens protein molecule. How? By binding the antibodies to the allergen and then using an enzyme linked conjugate to create a chlorometric change that can be measured. Or you can simply say that ELISA has that ELISA method is used in different food industries because of its certain benefits or because of its certain characteristics. For example, ELISA is the method, that is ELISA. It is very highly sensitive and has a very and ELISA is very specific. This method is very versatile as that at the same time it is flexible. It gives you a quantitative analysis and it is cost effective. It is very easy to use, and the process or the method is automatic, and it required a very minimal sample preparation, and it gives the result very rapidly. These are certain characteristics that makes ELISA used in most of the food industries. So ELISA, let's see the introduction part. ELISA was first introduced in 1960s and it has been around for quite some time. What is ELISA basically? So ELISA is a plate based technique that is used to detect and quantify peptides, antibodies, proteins, and hormones. So this method, that is ELISA, it is widely used in laboratory technique for detecting and quantifying the biomolecules. Biomolecules, for example, peptides, antibodies, proteins, hormones, and apart from detecting the or quantifying the biomolecules, it has a very high sensitivity and specificity. Now, how why it is used in food industries and why it has a so much application in food industries? So in food safety testing, ELI- ELISA plays an important role in reliably detecting contaminants such as mycotoxins and allergens, as already told you in the previous slide. It also helps to ensure the product safety, maintaining product integrity, and verifying the compliance with labeling regulation. Okay, now let's see the principal part of ELISA. So, on which principle does ELISA work, or you can say what is the principle of ELISA? So, ELISA works on the principle that specific antibodies bind with the target antigen, means the specific antibodies, what will do, they will bind with the target antigen, and after binding with the target antigen, and after doing that they detect the presence and quantity of antigens binding. So in order to increase the specificity and precision of the assay, the plate must be coated with antibodies with high affinity. ELISA can provide a useful measurement of antigen antibody concentration. Now I would like to tell you with with the help of one diagram. So before yeah, this is the diagram and this is how ELISA works. So again repeating, according to this diagram, as you can see, This ELISA, this is a widely adopted laboratory method that is used for detecting, or again I would say the same line, that it is used in quantifying the substances such as protein, means all sort of biomolecules. So now this method, what it involves, if you can see this, it involves a coating a plate with a specific antigen. As you can see, the antigen is coated with specific, the plate is coated with the specific antigen or antibodies, and followed by a series of reaction that produce a measurable signal, often a color change. Okay, so now let us understand this in detail, and we'll take different types of method, that types of ELISA. So the ELISA test can be classified into three types, depending upon the different method used for binding between antigen and antibodies. So the first method is indirect ELISA, second is the sandwich ELISA, third is your competitive ELISA. So coming to the first one, that is the sorry, but before going into detail, let us understand two words, that is antigen and antibody, because these two words I will be using again and again in explaining the types of ELISA. So antigen, what is antigen? So it is a toxic molecule, or you can say antigens are foreign matter, and that cause an immune response in the body, that is called an antigen, or simple in one word, antigens are the toxic molecule or any foreign matter. And what is antibody? So antibody, it is a blood protein that produced in our body by our immune system in response to counter react a specific antigen, means antibodies counter reacting with the antigen. Okay, now let us understand different types of ELISA one by one. So the first one is the indirect ELISA. Indirect ELISA, what it does, so it adds a layer, as you can see in the diagram, the second one, what it is doing, it adds a layer of amplification by using which antibody? The primary antibody specific to an antigen, and it labeled the secondary antibody that binds with the primary antibody. So this increases an assay sensitivity and flexibility, and allow for the detection of low abundance targets. So in particularly benefits for detecting the food contaminants, means how it is using in food industry. So because of this, it is beneficial for detecting food contaminants, and widely used in food safety labs for monitoring the hygiene and detecting the pathogens in a complex food matrix. Now the second one is the sandwich, and sandwich ELISA is been widely used. You can understand this with the image of a sandwich. How you eat a sandwich, means a sandwich has a two layer, and in between that two layer you had the stuffing. So in the same way, sandwich ELISA, it employ into two antibodies, as you can see this, as you can see, this is the layer 1 and this is layer 2. In between this is the materials that is packed between these two layers, just like a sandwich. Okay, so the sandwich ELISA, it employs two antibodies that bind to a antigen at different epitopes. These epitopes, it is effectively sandwiching it. This method offers a very high specificity and sensitivity, making it ideal for detecting food allergens at a low concentration. Now, this food production companies utilizes the sandwich ELISA to ensure that their products are free from harmful substances, complying with the strict food safety regulation. Okay, so and now the third one is the competitive ELISA. So what do you mean by competitive ELISA? So competitive ELISA, as you can see in the diagram, In competitive ELISA, sample antigens and label antigen they compete for binding to a limited amount of antibody. This format is useful for detecting a small molecules or toxins where two antibodies cannot bind simultaneously due to size constraint. Again, I am repeating that in competitive ELISA, okay, a sample antigen means antigen sample, they are labeled with the antigen compete for binding to a limited amount of antibody, and this format is useful for detecting a small molecules and toxins where these two antibodies cannot bind simultaneously due to the size constraint. And because of this thing, okay, because of its specific method, it is commonly used for measuring the pesticides, or you can say mycotoxins and other small contaminants in food sample, and this method is very valuable for food safety testing lab, and it mainly focus on detecting the low molecular weight substances that can pose a serious health risk. Now already we have covered the antigen and antibody part. Now moving to the next, that is how basically it's work. Now this is an example of ELISA, that is a sandwich ELISA. So a monoclonal antibody they are coated very well. After that, this antibody they are washed, and the antigen get binds to the antibodies, as you can see in the diagram. I'm marking it. As you can see here, antigen is binding to the antibody. The pink one is the antigen, and it is binding to the antibody. Again, it is further washed. Washing is done. After that, a second monoclonal antibody linked to the enzyme, as you can see, the second one is linking on linked to the first one. As you can see, the second monoclonal antibodies, they what they are doing, they are linked to the enzyme, bind to the immunobiolized antigen. Then further the washing is done, the substrate is added, and they are converted by enzyme into a colored product. So the rate of the color formation is proportional to the amount of high antigen. Now why ELISA is used? So in year 2005, FDA, that is Food and Drug Administration, has required a manufacturer to label their product with regards to 8 specific allergens. So what are they? They are milk, egg, fish, shellfish, peanuts, wheat, soya bean, and tree nuts. So these allergens they are responsible for over 90% of the documented food allergen related cases. So in 2005, according to FDA, all the manufacturer they have to label their product with regards to the 8 specific allergens. And what are they? These. So these allergens they are responsible, whether it's meat, milk, or eggs, fish. So they are basically responsible for over 90% of the documented food allergen related cases. And in the food industries, the two most common and preferred method for detection of allergens are ELISA and PCR. And yesterday lecture I've told you, I think the lecture number 8, we have already discussed about PCR, about its working, and why it is used in our laboratories, or in the food laboratories, why it is used. So now next, that ELISA in food industry. So ELISA method detect the actual allergen protein. How? By binding the antibodies to the allergens. Okay, once the antibodies get binds to the allergen, they detect the actual allergen protein, and then they use the ELISA, that sorry, the enzyme linked conjugate, and they create a chlorometric change that can be measured just like this. In this, as you can say, the color formation take place, and through this, what they do, they can detect it. So these are certain instance through and that ELISA method should not be used. So some metrics can interfere with the ELISA method, such as chocolate, or can cause over a cross reactivity as seen with different types of nuts also. So there is an exception. So where these method cannot be used, once you are doing for chocolates, so it is just avoided. Why? Because it can cause a cross reactivity. Okay, so this method is also not suitable for cooked as well as for the heat products. Okay, so there is an exception in using ELISA for certain products. For example, chocolates. In chocolates, ELISA could not be used. Why? Because of the cross reactivity. Apart from that, it is also not suitable for the cooked as well as the product that is have a high temperature, or you can see heated product. Why? Because proteins molecule, they get denatured. Once the protein get denatured at high temperature, and or you can say the broken down, the protein molecules, if they get denatured at high temperature or they get broken down, so in that particular case ELISA is not used. Apart from that, allergen is no longer detectable, but may still cause problem to a sensitive individual. Now I'm using a word, or you can say term, allergen. So what is allergen? So ELISA is properly used in food industries to detect the presence of allergens for legally required ingredients labeling, as already told you, according to the FDA. So this application of labeling or the food product, or for the presence of to detect the presence of allergens, so it is widely or has a good benefits greatly for the sensitivity of ELISA, and can detect the level of potential food allergens contaminants that are at a very concentration, or at concentration on the lower parts per million, that is ppm scale. It also has an advantage of being able to test for oils and other substances, for example oil, for example oil, as well as egg whites or milk, which alternative methods such as PCR are unable to detect. So yesterday only, sorry, yesterday I'm saying in lecture 8, I've already told you the method of PCR, where the PCR is used. So PCR is unable to used, or unable to detect certain food products, for example egg white or milk. So in this way, in that case, ELISA can simply help in detecting the milk or the egg whites. So these are certain big eight allergens already told you, that is egg, milk, fish, wheat, shellfish, tree nuts, peanuts, and soya. So in this case, ELISA is widely used. Now in product testing in food industries, it has a historical centered on detecting the contaminant that could cause outbreaks or illness. So there are various bacterial as well as fungal pathogens that were the primary agent for concern, followed by chemical contaminants. So, with today's high outputs and automated processing, additional contaminants such as food allergens are becoming an increasingly important issue in food safety. So, again, I would like to say that since food has so much microorganism pathogen, when food is not cooked, I'm talking about the raw food, it has a lots of pathogens. Okay, so how to avoid that pathogens? Different methods are used nowadays. Everything is automated, or they are using a very high throughput machineries or automated processing. So apart from the primarily agent, means the biological, physical or chemical or microbiological pathogens, one pathogens, or you can say one food allergens, one contaminant is widely there in different food items, and that is food allergens. And it is the duty of the industries to monitor the food allergens, and that is the reason different methods are used. And one of the best method for this monitoring or eliminating the food allergen is the ELISA. So this is very important for every industries to build, not build, sorry, to manufacture a food that is free from pathogens, as well as there is a new additional contaminant, that is a food allergens. Now moving further, ELISA also help in detecting the virus using viruses. This sorry, I've just written in detecting virus only. So the advantages of using ELISA for detection of virus is that they can be used in developing countries where infection rates are often very high, and can reach most vulnerable groups with on-site testing capabilities and instant result. So as already told you in the I think in the introduction part, where I've told you that ELISA, it is very it gives result very fast, it is very specific, and that is the reason it is used in detecting the viruses. Because in some of the countries there is so much contamination of food through different types of viruses. So for that reason, any method that can show a result very fast, or that can give a result very fast, so in that case ELISA is used. Again, I am just repeating myself that why is an ELISA important in food production. So ELISA play a very crucial role. This is the summary of the whole you can say topic, that ELISA play a very crucial role in food production. How? By providing a very rapid and an accurate detection of allergens as well as mycotoxins. And we all are aware that these mycotoxins are so harmful for humans, and they also play a major role in ensuring the safety and quality of food products. Okay, so their high sensitivity, or you can say their high specificity, make them an indispensable tool for complying with regulatory standard and preventing food safety incident. Okay, and for product that claim, even there are industries that claims that their products are allergen free or are sandwich. ELISA provide a very highly sensitive and specific means to verify these claims, so they are really ensuring that they meet safety standard and protect the consumer with food allergens. So since FDA has taken it very seriously that every industry should has the label of different kinds of food allergens, and yes, these ELISA is also working on the basis of key regulations and standard, for example FDA guidelines. So in US standard, or you can say yes, in the US it prescribed a guidelines for food safety testing that includes the application of ELISA, and particularly why it is used for detecting the allergens, for detecting pathogens, and for detecting the mycotoxins. Apart from FDA, ISO, that is one of the international organization of standardization, it also offers such standards such as ISO 22000 for food safety management system, which recognize the importance of ELISA in hazard analysis with the food production chain. So in this spaces, ELISA is widely used by different food industries, because see, what is the aim of every industry? So the basic aim or the basic thing that every industry wants is to manufacture the food, as well as ensuring that yes, the food is free from contamination or different types of pathogens. And with the help of these FDA approved guidelines, or with the different kinds of regulatory bodies, by using different contemporary method, these help every industry to manufacture a food that is acceptable for humans, because every industry is working or producing the food for human consumption. So why not to fulfill the demands of humans? So what is the demands of human? To have a food that has a high quality, that is free from any sort of microbial contaminants or any foodborne illness, any types of hazard. And yes, that food should be easily acceptable for humans. This is the only thing that humans wants. And to meet the human demands, every industries is focusing on the food safety with the help of different methods, whether it's PCR, whether it's illuminating methods, that is antibodies illuminating methods, or whether it's ELISA or many other methods. So these methods are approved, and yes, they shows result also that yes, now the product is free from any sort of microbial contamination. So that comes to the end of the lecture. I hope you have understood the lecture. If you face any query or any question is there, so you can simply leave your queries and your questions in the comment section below. In the next lecture, I'll be answering the questions. You can follow ITLS Academy on different platforms. This is our website, that is www.itlsacademy.com. This is again our helpline number, that is 7080833450. You can simply call on this number and get updated. Thank you for watching. Please do like, share and subscribe ITLS Academy. Thank you so much.